In this one, we're just going to take a look at solving some problems with right angle triangles. So a couple concepts just to cover in terms of terminology. That is the angle of depression or declination, decline, and then the angle of elevation or inclination, or incline. So the way these are measured is that we have a line given to us, such as this here, and then it's the angle of depression would be if we had a horizontal line, then it means it's going down from the horizontal line. In case of elevation, if we measure out a horizontal line, the angle of elevation is going up from the horizontal line. So we're elevating from horizontal. You can think of this by holding your arm straight out. If you start there, the angle is made by depressing or lowering your arm and then elevating or lifting your arm. And you have drawn out your angle of elevation or depression. Okay, so just a problem. This is a common type of problem that we'll see with trig, and that is, again, finding the height of structures that we have difficulty measuring because climbing up things is sometimes hard to do. So here, Tom is measuring the height of a building by standing on a shorter building's roof, and then he measures the angles to the top and bottom of the taller building. He knows the buildings are 25 meters apart. He measures the angle of elevation as 60 degrees and the angle of depression as 30 degrees. What's the height of the taller building? So here we got a couple buildings. So I'll just quickly draw a pair of buildings here. I'm going to give a little gap so I can draw. So I got a tall building, I got a short building. Just a diagram here. So here's my tall building. Stands out. Here's my short building. So from the top, here's Tom over here standing up here, measuring out his angles. And so what he knows is that this here distance is 25 meters. And then he measures the angle of depression. So here's our horizontal from the top of the building. So the angle of depression would go down from there. So the angle of depression goes down this way, and that is 30 degrees. And then the angle of elevation would elevate from that point up to the top. And that is going up 60 degrees. Now, this would make a right angle with the ground. This would be a right angle off the horizontal. And we have a couple triangles that we can then use to solve some information about. So this height here, in this triangle with 30, well, we could say that's 25 meters across. So we have the adjacent side and the opposite side. Opposite and adjacent is going to use tan. So we can find this height here. We'll call this x, and then we'll find height y. And again, with this one, that's the opposite, that's the adjacent. So here we're using tan twice. So the tan of x, tan theta equals the opposite over the adjacent. We're going to have two equations. In this case here, we have tan 30 equals x over 25. And in the second case, we're going to have tan 60 equals x over 25. So now we just tabulate these. Tan 30 is going to give me 0.5774 equals x over 25. So we're just multiplying 0.5774 by 25 to get x. And when we do that, I get approximately 14.4 as my x. And then I guess this one's not x, this is y over here. But tan 60 is going to give me 1.7321 equals y over 25. Cross multiply that 25, we get 1.7321 times 25 equals y. And so if I do 25 times 1.7321, I'm going to get 43.3. And so the height of the taller building is x plus y, so 14.4 plus 43.3, which equals 57.7 meters. So our taller building is 57.7 meters. So you can use this as a starting point. We're basically just going to be using multiple iterations of the sine, cosine, and tangent laws in questions to solve for various parts along the way. You may have to find one portion before you can find the next portion, before you can find the next portion, kind of thing. Again, angle of depression, angle of elevation. Make sure you know the difference between those and how they work. Off the horizontal, depression is coming down off the horizontal, elevation is coming up off the horizontal.